Good morning, students. Now, the other part of this topic, system of particles and rotational motion, we are discussing rotational dynamics. In the circular motion, just simple terms we discuss V, omega, R, and centripetal force, centrifugal reactions, centrifugal forces, etc. Now we are discussing is rotational dynamics. This mainly deals with the rigid bodies also. One topic is term we are going to discuss here is torque. Definition, one mark question. It is the moment of force. It is the moment of force. It is the product of force and perpendicular distance. You can also say other way. It is the product of force and perpendicular distance from axis of rotation. And perpendicular distance from axis of rotation. It is a moment of force. The word, you have to be careful with the word, the term moment of, moment, M-O-V-E-M-E-N-T, movement is it. Another one is we are using is momentum, and now we are using is moment. If you talk about the movement means motion. Word is related to object in motion, is related to movement. Whereas the momentum is the product of mass and velocity. That symbol we take is P. P is equals to mass into velocity is momentum. Next is movement, M-O-M-E-N-T. Movement is nothing but a product of distance. Distance into anything you can take. Distance into mass, moment of mass. Distance into force, moment of force. Distance into momentum is angular momentum word we use it. That is related to momentum. Moment of momentum, angular momentum. Moment of force. Moment of force means force into distance or distance into force. And moment of momentum, we are going to use the term as angular momentum. Moment of momentum means a distance into linear momentum. This linear momentum is the term we are using for the straight line motion. The term when you multiply with the moment means distance into something. What is the distance is? The perpendicular distance from the axis of rotation is nothing but the distance. Perpendicular distance from the axis of rotation, that is nothing but the radius of the circular path we can imagine at that instant. That means you are talking the radius means that related to rotational motion. The torque is similar to the force in the transitory motion. What is the force formula we take is F equal to mass into acceleration. What is the force? Force is a physical quantity which changes or try to change the state of rest, motion or direction of the object. And whenever it is trying to change the state of the rest, motion or direction of means what? It is changing the velocity. Velocity direction or velocity magnitude. When it is changing that, it is producing the accelerations. So F equal to ma is this force supposed to be external force. Only external force can affect the momentum changes or can affect the resultant motion in the object. Similar term we take in the rotatory motion is called as the torque. So wherever the force is there, replace with the torque. And wherever the mass is there, we are going to take the term called as moment of inertia, I, and wherever A is there, we are going to replace with that as alpha. These terms we will discuss later. Just know that for linear motion, if I want to move the object straight line path, if your object is moving in a straight line path, starting from rest or changing its direction or already moving, decreasing velocity, the force required, we are taking F equal to ma. But if you want to rotate the object, fan is there. If you want to rotate the fan, already it is rotating, you want to stop it, or you want to change the direction of rotation, the physical quantity required is called as a torque. Torque is provide the rotating effect in the objects. If you are already rotating, try to stop the rotations. So that is the external torque. Similarly, external force we take now, we are going to take the term as external torque. External torque can only affect the rotations. Torque provides rotational effect or rotating effect in the objects or rigid bodies we are going to discuss. Rigid means hard bodies. In vector form, torque, the symbol is taken as a tau. You have to read that as tau, tau, Greek letter. It is a straight line. Actually, vertical line is a slightly curved line. Top is also curved line, like a wave you have to take. This is also curved, this is also curved, but generally we write a straight line and curve on the top. Compulsory take curve on the top, don't write a T. It is not T, you have to take it called as a tau. Tau, tau. You have to read it as. In vector form, torque, tau is equals to R cross F. Torque is equals to R cross. That means torque is the cross product of radius vector. It is taken as also position vector and the force. Torque is the cross product of position vector of point from where your force applied, actually, that is R bar, and force F bar. So according to the cross product, if you take the C bar is equals to A cross B, then C bar is perpendicular to both A and B. So torque is supposed to be perpendicular to both R and F. So if you take this magnitude, what you take? Magnitude of torque, tau is equals to A cross B, magnitude is AB sin theta. So torque is equals to RF, means this becomes equal to RF, or FR we can take into sin theta. This R sin theta is called as a perpendicular distance, and F force into perpendicular distance from the axis of rotation. Then what is position vector means what? It is a point where the force is acting compared to the distance from the axis of rotation. I will draw the diagram for that, you will come to know it. Where R sin theta is called as a perpendicular distance I will take it as R perpendicular, R sin theta is perpendicular distance of force, simply called as a perpendicular distance actually, from axis of rotation. This becomes equal to rotation radius also, but not always need to be radius of the circle. Just at the instant you are applying, where it is applying is important for this. R sin theta is the perpendicular distance, means torque is nothing but equal to force into perpendicular distance. Perpendicular distance is the distance only. That means the moment of force. R sin theta is the moment distance into force F becomes equal to moment of force. Force into perpendicular distance is nothing but called as a torque. What is the effect of torque? Is rotating effect. Torque provides the rotating effect. Try to rotate, or if rotating is trying to stop also, what is required is a torque. Opposite torque. If you are already rotating, if you want to stop, means the force, the torque applied is called as anti-torque or counter torque. And how can you increase the torque? What is the values of the torques? If the force is more torque. More distance from the axis of rotation, more torque. More theta, up to 9 degrees when you can increase, torque also increases. So if you take the diagram for this is a z axis, this is a y axis. I am giving the diagram based on this textbook diagram. It's not necessary that you have to take this as y axis, you can take x axis also, doesn't matter. This is a x, y and z axis according to the textbook given, and force applied from on this object here. So the object is here, our point is here. The position vector from here to here is R bar we take, that is position vector, and force applied in some particular direction like this. This is the direction of the force applied. Then the position vector distance from here along this R, extend it further. This is the position vector distance. The angle should be measured at the tails in contact, but position vector is always the distance from the origin to this point where the force is applied. The angle between these two, R extension is this point, this is nothing but R bar, and angle between the R bar and F is supposed to be theta. So at the tail point only you take the angles theta, and take this F this side. This is going to be the perpendicular distance of the force. Expand the force backward directions like this. This is going to be 90 degrees, this is 90 degrees. Then this is going to be R perpendicular, this is going to be R. The R known angle set what is the cos component in this direction, but perpendicular direction we require. Perpendicular to the force. Perpendicular force is this one, that is here, that is equals to R sin theta. R perpendicular is nothing but equal to R sin theta. And what about the torque then? It is actually three-dimensional diagram. We are not able to draw it properly because the axis is like this. Here force applied in this direction, some other directions, and R in these directions, expanded backward directions. This is a perpendicular distance, and torque will be acting perpendicular to R and F. Torque is the cross product of position vector R and F. What is the direction of torque? Torque is perpendicular to tau is perpendicular to R bar comma F bar. So this is the direction of the torque perpendicular to the radius position vector R. This becomes equal to torque. If it is moving in a circular path, then this R bar becomes equal to radius of a circular path. This torque is perpendicular to R cap. In the diagram this should be approximately 90 degrees. This is going to be, this need not be exactly opposite the torque place. If this R sin theta is perpendicular to the force, you have to take 9 degrees. R sin theta is a perpendicular distance. This formula is important for the numericals, this and this also. What is the direction of torque is perpendicular to R and F. What is the direction of that? It is along the axis of rotation. I didn't mention anywhere. Tau is along axis of rotation. Torque is along the axis of rotation. And units what we can take for the torque, one is torque is a vector, it is a distance into force only, Newton into meters. Sin theta don't have units, so torque is nothing but equal to force into distance means Newton meters is the unit we can take, and direction is along the perpendicular along the axis of rotation of the object. What is the function of torque is rotation. And how can you increase the torque? More easily can rotate the objects. To increase the torque, what we can do? Theta can be made 90 degrees, sin t is 1. Another one is increase the force. For a given force, what you can do is increase the R value. More is the distance from the axis of rotation, more will be the torque. So in case of the doors, if you take up, check up doors, if you see the doors, handles are provided at end points. Why it is provided at the end points? If you are moving the door with your at the handles, the door is actually rotating around this vertical line of the hinges. That is nothing but axis of rotation we call it. This is the axis of rotation. So when you are rotating when you are moving the door, actually it is rotating around this axis of rotation, and the distance from the axis of rotation to the force you are applying itself is R. You can apply the force at different angles. If I pull the door, what happens? Force and radius are in the same direction. Radius is always directed away from the axis of rotation place, away from the origin. Radius vector is always away from the origin. Position vector also away from the origin only we are taking. So the handle is provided at this point at the distance R. R is always away from the axis of rotation. And R and F are same direction means what? Theta is equal to 0. Theta is 0 means sin 0 is 0. The torque is 0. That means if we are pulling the door, the force is there, R is also there, but theta is sin 0 is 0, then torque is 0. When torque is 0, there is no rotation. Torque is required for rotating objects when they are at rest or to stop the rotating object. Next, I am applying the force towards the axis, pushing. This is a force. I am pushing the door towards. When I am pushing the door, this is a door for example, you can rotate like this. I am applying the force. First I am pulling like this. Radius vector is away from the axis of rotation. Force also away from it. Theta is 0. Same direction means. Now I am applying the force toward the axis. When applying the force toward the axis, R is away from the axis. Theta is 180 degrees. Sin 180 is 0. Again torque is 0. There is no rotation of the door. But if I apply the force at any other angles, then the object starts rotating. So in that case, if I apply the force at 9 degrees to the radius, then theta is 90, sin 90 is 1, torque is maximum. So maximum torque is possible when R is equals to, when R is perpendicular to F. And what is the direction of the torque is? This is the direction of torque. R and F. Now F is applied like this. R and F are perpendicular to each other, or may not be, whatever the angle you take it, other than 0 and 180, there is a rotation. And theta 90 means maximum torque is possible. And this torque is perpendicular to the radius is perpendicular to the force. Then theta is 90 means torque, R and F, all are perpendicular to each other. But whatever, the torque is compulsory perpendicular to the R and F. Torque is perpendicular to R and F, and torque acts along the axis of rotation. If the rotation is anti-clockwise in the diagram, if the rotation is like this, anti-clockwise, what is the direction of torque is? Keep your hand on the plane of rotation, the thumb indicate direction of the torque. So if you are rotating the door like this, on this plane of rotation, it is rotating like this. On the plane of rotation, keep your right hand, curling fingers indicate direction of rotation, thumb indicate the direction of the torque. And if in case if I rotate in the opposite directions, like this, it is applied, the torque is rotating or pulling the door. It is rotating like this. Then you have to keep the fingers like this. Curling fingers, direction of rotation, torque is downwards. that indicated by the thumb of right hand. The special case we discussed for the different theta's. And if r is 0, what happens if I apply the force at the axis of rotation? Not here, I am applying the force here at axis of rotation. R is the distance between F and the axis of rotation is r. The theta is going to be r is 0. When r is 0, torque is 0. That means if we apply the force at the axis of rotation, there is no rotation because torque is 0. That means handle should be provided, should not be provided near the axis. The handle should be provided far away from the axis. That means the r is more. When the handles are provided far away from the axis, r is more. When r increases, torque also increases. And in the villages, you will find the grinding stone. The grinding stone is used to grind the grains, dry grains. It is two heavy stones are kept one over the other with rough surface in between, and the top one is able to rotate freely, and the grains are poured into the hole here. Due to the centrifugal force, when they rotate, no, the grains will be pushed away from the center and they fall out. And as rotated, whatever the handle is provided here, the handle should be provided away from the axis of rotation. More distance you have to keep. You should not need this handle close to the center. It is provided at the corner edges only. Why? R is more. When R is more, the force you are applying can be less also. More R, more torque. More torque, more easily can rotate the objects. So torque provides the rotating effect. Torque provides the rotating effect. More torque, if torque is high, the rotational object is easy to rotate the object. If torque is large, then it is easy to rotate the object. If you want to stop the rotating object, what is for torque required? Opposite torque, that is called as a anti-torque is required, or called as a counter torque. To balance the torque, the equal and opposite counter torque is required. It is also called as anti-torque. One rod is there about this axis, and one person is pushing with the force this direction. This is going to be R1, the force is F1. So it is trying to rotate in the direction. But one more person is applying the force in opposite directions, F2 at distance equal to R2. One torque is trying to rotate in one direction, other torque is trying to rotate in opposite directions. So when it is not rotating, means called as equilibrium. At equilibrium, net torque is 0. Net torque is rotational equilibrium, please. There are different type of equilibriums. In the mechanical equilibrium, we are talking about the translatory motion at rest. Means there is no translatory motion, means forward force equal to opposite direction forces. Equal and opposite, net force is 0. But here talking about the rotation. When you switch on the fan, inside the electromagnetic field is produced which rotates the fan. Then to stop the fan, the rotation of the fan is provided by the torque produced by the electromagnetic field inside. So if you take a stick and try to stop the rotation, what you are providing is called as anti-torque or counter torque. Both must be equal and opposite. So net torque is 0, torque net equal to 0 means that is supposed to be equal to tau 1 plus tau 2 is equal to 0. That means tau 1 is equals to minus of tau 2. What is tau 1? F1 R1. What is tau 2? F2 R2. Why F1 R1? Torque formula what we have taken is RF sin theta. Theta is 90 degrees, and because here force applied perpendicular to the radius length, so theta is 90, sin 90 is 1. So maximum torque we are considering here, torque 1 is equals to F1 R1, torque 2 equal to F2 R2. Both are equal and opposite, means the net force, net torque equal to 0. This is called as a rotational equilibrium. We are going to discuss about this rotational equilibrium again later. Rotational equilibrium, net torque is 0. That means there is no rotation. To balance the torque, the equal and opposite counter torque, C-O-U-N-T-E-R. Counter torque is required. It is also called as a anti-torque. First point, if torque is large, then it is easy to rotate an object. And torque formula what you have is torque tau is equals to Rf, vector form we take R cross F, and magnitude tau equal to Rf sin theta. What if I take F cross R and tau equal to minus F cross R, A cross B equal to minus of B cross A, that means minus tau you will get equal and opposite directions. A cross B equal to minus of B cross A. Negative indicates in vector what? Opposite directions. Magnitude means rotation is considered, whether you take R cross F or F cross R, it becomes equal to Rf sin theta. Rf sin theta. These two formulas you need to remember, and these are required for the numericals. Special case under this we take. Tau is 0 if R is 0. First we will take if R is 0. If R is 0, torque is 0. No rotation. On object at rest. Even the force is there, no rotation possibility. Next is if theta is equals to 0 degrees, that means RF same direction. Same direction or parallel we can take. On this rigid body, force applied away from it, R is also away from it. Theta is 0, that means again sin 0 is 0, therefore torque is equals to 0, no rotation. Next, if theta equal to 180 degrees or opposite to F in opposite directions or anti-parallel, sin 180 equal to 0, torque is also equal to 0. In this case we are applying the force. This is a rod, radius is away from center, force is toward the center of axis of rotation. This is the axis of rotation. Then torque is 0. When torque is 0, no rotation. No rotation effect we can take. And whatever torque we are taking, this torque is supposed to be external torque place. It is supposed to be external torque if you want to get any effect, not internal torque. What do you mean by the external torque? If you are sitting on the fan, you try to rotate the fan. The force, the trying to rotate the fan by sitting on the fan, that is internal torque we count. So up to apply the force, you are sitting on this only and pushing in this direction. That is action. But your body will be pushing in opposite direction. There will be reaction forces. So equal and opposite reaction forces provide the anti-torque and torques, which will be cancelled each other. But if you take a stick from outside and rotate the fan, you can rotate the fan. When it is at rest, which power is not on, take a stick and push that wing, fan blades, then fan starts rotating. It's possible to rotate from outside applying the force at some distance. That is external torque we are providing. But if you are sitting on that fan only and trying to push it, you cannot rotate that fan. That is because the torque is internal torque. Internal torque cannot produce the resultant motion. External torque can only produce, same as the internal force, external forces. You can push others. When you are applying the force on others, your force is the external force. You can push the car from outside. If you are sitting inside the car and trying to push it, engine is off, but you are pushing it. When you are pushing it, the action force is acting forward direction on the car, and the seat is fixed to the car only. Your body will be pushed backward directions. One is action, another one is going to be reaction. Action reaction acting on the same bodies will be cancelled. That is Newton's third law. F action equal to F reaction, and F action reaction acting on the different bodies can be possible to produce the resultant motion. But if they are acting on the same body, they will be cancelled. So action reaction will be cancelled if they are acting on the same bodies. So if you are pushing the car from inside action, same your body is also pushing backward direction, reaction acting on the same car internally inside. So net force will be 0. There is no resultant motion. But if you are standing outside the car and applying the force, now we are going to apply the external force. That is action. The car is applying the force on you, that is a reaction, but they are acting on the two different bodies. In such cases, it is possible to move the car if it is not applied brakes, or if the friction between the tire and ground is less. It is possible to push the car. It is possible to push the aeroplane also. If you have a little strength and friction between you and ground is required, the friction between the vehicle and ground should be very less. Then it can apply the force from outside and it can move the objects. That is going to be external force. External force can only provide the resultant motion. You can push the other person, but that is external force. But you cannot push yourself, you cannot lift yourself, you can lift others. Lifting yourself means what? Action reaction in the same body will be cancelled. But if you are lifting other person means that is going to be external force. It is possible to move the objects or provide the necessary change in momentum in the objects possible only when you apply the external force. So here also we are talking always torque resultant motion you are discussing means we are talking about external force, torque only. Without mentioning also you mean just external, not mentioned also, just think it as external torque. Only external torque can affect the resultant change in the rotation of the object. Next case we take is that theta is equals to fourth point. If theta is equals to 90 degrees means what? R is perpendicular to F bar, normal to each other. That means you are taking the rod like this or door, this is R, but the force is applied like this. Theta is going to be 90 degrees. When theta is 90, sin 90 is 1, that is maximum values. Therefore, torque equal to RF sin theta becomes equal to RF. This is the maximum torque. Torque is maximum when theta is equals to 9 degrees for the given R and F. We'll stop here now.